Greetings everyone. I am Viresh Ranjan or the topic that I have selected for the PPT is the Bodmas logical circuit. First and foremost, when we had the elongated mathematical expressions, we used to have a rule called as Bodmas rule. That is bracket of for division, multiplication, addition and subtraction. So using that tool, we used to solve elongated mathematical expressions in our lower classes. Similarly, when such a elongated mathematical expressions is given to a computer or a calculator or any electronic devices, it also just simplifies that elongated expression and gives the answer perfectly according to the Bodmas rule. It's because of presence of Bodmas logical circuit which is present in them. Yes, we do have a Bodmas logical circuit. Let's see what it is. So, before going for the logical circuit, let us make sure what do we need to make the logical circuit. Since it is a logical circuit, we need logical ICs. That is, one NOT gate. 74004 is a NOT gate. It contains 6 NOT gates. Hence, it is called as X inverter. So NOT gate is nothing but an inverter. That is, when we give 1, it gives output as 0. When we give 0, it gives output as 1. It gives the complement of the input as the output. So 7404 is a NOT gate. And two more ICs, that is 7408 and 7411. Both of them are AND gates, but 7408 is a 2 input AND gate and 7411 is a 3 input AND gate. So the output of AND gate is high only when all the inputs are high. Otherwise, if any one of the input of the AND gate is low, output will be definitely low. So saying this, and three more components is LEDs to indicate which has the highest priority. We need to have LEDs as well as switches. To give the inputs to the circuit, we need switches, and to limit the current, we need resistor. So the working is this. As you see in the diagram, BODMAS push button switches are present right there to indicate respective bracket of division, multiplication, addition and subtraction. So when we just press any of those buttons, say for example O, D and M, that is switch 2, 3 and 4, when three of them are pressed together, the respective ODM LEDs, in those three LEDs, the O will be high. It's because of O has the highest priority than the other two. Similarly, when BOD are pressed, B will be glowed because B has the highest priority. So in such a case, as we already know that Bodmas is a priority-wise distribution of operation among the elongated mathematical expressions. So in here also, we will just have these kind of circuits built embedded inside of electronic devices, so that when it comes across a very long mathematical expressions or arithmetic expressions too, then it evaluates the expression using this rule. So that's because of the presence of this circuit, as you already see. To be frank, it's a priority encoder. Yes. For example, S has the lowest priority. In order to make the S LED glow, we need to press only S. Other than that, if any other button is pressed, that respective LED will be glowing. Similarly, B has a S priority. If B is pressed, no matter what other keys are pressed, B will always keep glowing because the B has the highest priority among all. That's how the circuit works. As you already see, the NOT gates, with the help of this NOT gates and AND gates, the circuit is made. So these are the working of the circuit. Now, our topic or whatever, the subject which we take becomes successful only when it has applications, isn't it? So, first and foremost, we use in real-time lifts, because when two persons, one is on the fifth floor and one is on the seventh floor, presses the button for the lift, and the lift is at the ground floor, then the lift services the person who is not nearer to the lift but who has pressed the lift before the other. That means the time division priority takes place in the lifts. Similarly, in electronic calculators, as I already told you earlier, in ALU of microprocessors, absolutely. Similarly, when two devices require to transfer by accessing the same communication medium, in such a kind of situations, these kind of circuits, I mean Bodmas logical circuit, can be used not only as Bodmas but other arbitration circuit. The same circuit we will use as an arbitrary circuit which decides which the device has to send the data. Similarly, of course, to encode the output of a flash type ADC, we need this Bodmas logical circuit. And when microprocessors and controllers have two or more interrupts, and when those two or more interrupts are activated at the same time, then we'll have a question which has to be serviced first. So to set priority, we'll be just using the Bodmas logical circuit. Then the cost estimation comes. Like as you see in here, just for 255 bucks you can make this circuit. It's very simple, but it's a physical circuit which will be done on the breadboard. Actually I did with the help of my friends, but to make it embedded circuit it requires even more it's even more difficult to implement, as well as more price. So as you can see, this is the circuit I made with my friends. It's a Bodmas logical circuit. We have 6 push button switches on the left to give input for respective BODMAs. Similarly, we have 6 buttons, I mean 6 LEDs on the right to indicate the output which has the highest priority. Which has the highest priority, setting for BODMS itself, respectively. And finally, these are the references of websites in which I went through to get the idea of this circuit. Thank you.